Welcome to this operations management tutorial video on facility layout, focusing on a product layout or line balancing. In this video, we're going to cover the steps of organizing a product-oriented layout. To do so, first we must identify all the tasks required in the production process. Second, draw a precedence diagram. Third, compute the total time required to produce one unit. 4. Compute the takt time. Number 5. Compute the theoretical minimum number of workstations required on the production line. Number 6. Assign each task to a workstation. This is where we balance the line. And then finally, evaluate the design of the production line. So we'll start off with identifying all the tasks, and for that job we are turning to the textbook and using the story of Lenny's lawnmowers to give us data for our production line. And then we must draw a precedence diagram, and the way we read this data is that we must look at all the individual tasks and see what any predecessors are, and as we draw a network diagram we must honor those predecessor relationships. So we can see that task A has no predecessor, so A can begin and is not dependent on the completion of any other task before we can begin A. B is dependent on A, so once A is completed we can begin task B. Again, we have to mount the chassis for assembly, for example, as A, and we can't attach wheels until we have mounted the assembly. So task B in this case, in this example, is dependent on task A being completed before we can start it. Likewise, task C is dependent on task A as well. It's not dependent on B, so we draw an arrow directly from A to C, denoting that C cannot begin until task A is done. We continue. D is dependent on B. Again, we must have the engine, or rather the assembly and the wheels attached in this scenario before we can attach the engine, task D. And if we continue in this same manner down this list of tasks, our network diagram will look like this. Again, we've honored all of the predecessor relationships in where we've drawn the individual tasks and the arrows. Okay, so we've done task number 1, or step 1 and 2. We're going to move on to steps 3, 4, and 5, which will be done in Excel. We must compute the total time required to produce one unit, calculate the takt time, and then calculate the theoretical minimum number of required workstations. So for this, like I said, we will jump over to Excel. And here we have our data, the same data from the Lenny's lawnmower example in the textbook. And the first thing we must do is compute the total time required to produce one unit. Well, we have the duration in minutes for each of the tasks in the assembly of this lawnmower, and to get the total time we simply do a sum formula, grab all of those individual durations, and the total time required to produce one unit is 33 units. Okay, next we must calculate the takt time. Kind of a funny word, T-A-K-T. Takt time is the heartbeat, or the beat rate at which we must complete a unit in order to meet the demand. So we are told that our desired output is 80 units a day, and we have one 8-hour shift in which to complete those 80 units. Well, one 8-hour shift is equal to 480 minutes. 8 hours times 60 minutes per hour gives us 480 minutes. So we have 480 minutes to complete the 80 units. And so as we see up here in the formula, we take the total work time available, 480, divided by 80, and that'll give us a takt time of 6 minutes. I'm just going to input that formula right here into Excel. Total available time divided by the desired output, and a takt time of 6. Now the theoretical minimum number of workstations is derived by taking the total time to complete one unit, which is 33 units, divided by the takt time. And so if we do this, 33 minutes total time required for 1 unit divided by the takt time, and we get 5.5 minutes takt time. So that is, or rather 5.5 is the theoretical minimum number of workstations, but we always round this number up to a whole number. We can't have half a workstation, so I'm just going to type round up, and then we'll do so with a 0 decimal places, and that gives us 6 is the theoretical minimum number of workstations. Now we're going to move on to the next steps, which we will do back in PowerPoint. Okay, so we're going to assign tasks to workstations. We are told our takt time is 6 minutes. So what that means is our assignment of these individual tasks to workstations cannot exceed 6 minutes total. And what we're going to do is we're going to organize all of these tasks into a linear production line. So if we look at this, we can have a workstation that would be composed of task A and B. That would be 6 minutes, so we're not exceeding the takt time. Or we could do A and C. That would also be an acceptable workstation number 1. And as we assign these tasks to workstations, we must also honor the precedence relationships as outlined or as depicted by the flow of arrows here. So in this case, we're just going to say workstation 1 is composed of tasks A and B. And please note, when you do the homework is going to guide you in such a way that it's going to limit what your options are. So because there are lots of options often with the production line, how you organize it. If you think of an auto manufacturer, there's a lot of ways they could sequence the work. But for the purposes of these exercises, we're going to kind of guide you in a certain way so you don't get those too many options to choose from, to make the homework simple and doable. All right, workstation 2, tasks C and E, again, 6 minutes. We're less than or equal to the takt time. Workstation 3 is composed of task D. Task D is 5 minutes, and we really can't combine it with anything else because it would exceed the 6-minute takt time. So D is by itself in a workstation. Workstation 4 is composed of F and G, again 5 minutes total. Workstation 5, H and J. Workstation 6 is going to be I and K. And if you think of it, we've honored all of the predecessor relationships. And then what we would do, if we were setting up this line, we would then reorganize those tasks in this linear fashion. And this is what our production line would look like with the 6 workstations. Okay. So the next thing we're going to do is 7. But let's go back into here. And I want to make a note here that our actual number of workstations was 6. Now sometimes when you do these kinds of problems, the actual number of workstations will be greater than the theoretical minimum number of workstations. So if that's the case, we must use the actual number of workstations for purposes of these subsequent calculations that we're going to do now. Now the cycle time is nothing more than the maximum time that is assigned to any given workstation. And we saw that there were several workstations that had 6-minute total time. It could have been a task of 4 minutes plus a task of 2 minutes within the same workstation. So that was this cycle time. So I'm just going to put 6 here as our cycle time. And now we're going to do step 7, where we evaluate the design of the production line. We've identified the cycle time. Now we have to find the total idle time and then measure the efficiency of this line. To get the total idle time, we take the actual number of workstations times the cycle time minus the total task time. So in this case, we have the actual number of workstations, which is 6, times the cycle time, which is also 6, minus the total time required to complete all the tasks, 33 minutes. And so we have 3 minutes of idle time. Now, we're not being asked what the percentage of idle time is, but if we did that calculation, we would look at the idle time, 3 minutes, divided by the total work time available, which is 36, and then give us 8.33. But in this case, we are asked to identify the efficiency or calculate the efficiency. So again, we take the total task time, which is 33 minutes, divided by the actual number of workstations times the cycle time. So we'll input this here, equal to 33 minutes divided by, and we're going to open up parentheses here, the actual number of workstations, which is 6, times the cycle time, which is also 6, and that gives us 91.67%. Well, I hope this tutorial video will be helpful to you as you tackle the product line or line balancing problems in this week's homework.